something that is used to make decisions, something people use to take your money. If you're a gambler, they know the probabilities, the house wins, all kinds of things to use for probability. In a nutshell, probability is the number of desired outcomes, what you want, how many are there, over the number of total possible outcomes. It can be written as a decimal 0 to 1 because all probability is 0 to 100%. So in decimal form, that would be 0 to 1. It can be written as a percent, 0 to 100%, or a fraction in lowest terms. There's never a negative and never anything over 1 for probability because there's no probability higher than 100 or in the negatives. Okay. Okay. The main things you need to be, you've got the basic ones, and then you have the ones with and or, that needs some work. Just one basic one. You always need a total. And they don't usually put cards on the test because not everybody is a card player. I don't like that they do that, put the cards in there. But number 4, a card is selected at random from a standard 52 card deck. What's the probability it is a queen? So you have to have played cards to know our total is 52, our desired is 4. 4 over 52 reduces to 1 over 13. What's the probability it is a club? Well, there's 13 of each suit. It reduces to 1/4. There's 4 suits. What is the probability that it is a queen or a club? Well, there's 4 queens and 13 clubs. So you would add those together, but you counted the queen of clubs twice. So you have to subtract that one out and you get 16. So 16 over 52 is 4/13. So that is the basics. If anybody has any specific questions on this section, you can let me know, or I'll go straight to the quiz for this one. Anybody have any questions in 16? Okay. Always start by determining your denominator. Who are you picking from? How many total are there? What is the probability that a rat chosen at random is long-haired? So we're choosing from all the rats. So always start with what you're choosing, and then out of that, how many you have that you desire. So what would be the denominator?
190.
190.
Yep. So out of the total 190, how many total long-haired do we have? And then you need to reduce it, and that would be 7 over 19. Okay. Now, WebWorks was taking decimals. The quiz is saying fraction reduced to lowest terms, so make sure you follow the directions. Okay. What's the probability a voter is either male or Democrat? So who are we picking from again? What's our denominator?
802.
We're picking from everyone. It's 802. And then this is, you got to be careful of or and. If it's or, if you meet either of these qualifications, you count. So a male, look at the total males. We have 397. But you don't have to be both things, it's just either. You could also be a Democrat, which if we look at the total, it is 253. Now this is the formal statistics method, probability of A plus probability of B. Then you have to subtract A intersect B. Okay. All that means is we counted this 103 in this column and in this row. You can't double dip and count it twice. subtract the 103 out. Now, if you just want to do, here's the total males and then add in the females, 150, that works too. If you went 397 plus 150, we're going to get the same answer. This formal one would be needed if you had much larger charts where you had to do a lot of deducting. The formula would work better, but you don't need to use the formula. You can just count up all of them and don't double count any of them. And what do we get for our numerator? Anybody working it out for me?
$547. Oh, sorry. You already got it up there.
Yeah. Over 802. And that is as reduced as it gets. Okay? Do you understand the or? That means it can be either one of those things. Okay? Be very careful. Some people go too fast on these. They should be easy ones for you. It makes sense, but watch the wording and an or. Okay? What is the probability that a rat chosen at random is short-haired and male? So again, we're picking from everyone. Now they have to meet both criteria. They have to be male and short-haired. So this time we want where those intersect. Who has both of those things? And it would just be the 65. That would reduce to 13 over 38. Okay? Do you see the difference between and or?
Yes.
Yeah, can you show the or one more time? Computer glitched and I had to sign back in.
The one before this? Did you say
yeah,
show?
Please.
Okay.
Sorry, everybody.
I'm sure there's some people that needed to see it again anyway. Okay. It says either male or Democrat. That means you just have to meet one of those two criteria. So we take the total male, which was 397, and the total Democrat, which was 253. But you have to be careful because you counted, see where they intersect? You counted those people twice. They can only be counted once. So you subtract out that intersection where they intersect, that row and column, because you counted them in the total here and in the total here. Okay? That adds up to 547 over 802. Make sense?
Yes, thank you.
Okay. Okay, that is all on this for probability. I do want to do a conditional. Who can tell me what conditional probability is? Anybody?
What is it?
That's one is
If or given?
or given.
Perfect.
I'm sorry, Tim.
No, that's good.
No, you're fine.
That means something has happened already. You're not selecting from everyone. Okay? So for instance, this is not one. Okay, I thought I found one. That is not one. I'm sure we have one somewhere. Okay, my number 10 here. Here's my numbers. The person is randomly selected. What is the probability the person is colorblind given the person is male? Okay, so that means you're only selecting from the males. Everybody else is out of the running. You know it's only males. So your denominator is 120, not the 180, because they already told you a male was selected. Okay? And then out of those 120 only, how many are colorblind? It is 65. 65 over 120 becomes 13 over 24. That's conditional. B just says how many are male. That's not conditional. Nothing has happened. So we're back to 180 with the denominator. What's our total males? 120 reduces to 2/3. On C, it says what's the probability of a male given the person is colorblind. So now you're only looking at the colorblind people. How many do you have possible? 99. That's your denominator. Out of that 99, what's the probability they are a male? So your numerator is 65. You get 65 over 99. So you can have an and or an or. You can have a basic probability, or you can have conditional probability. Make sense?
Yes.
Yes.
Okay.
Yep.
All right.
Yes.
We'll move on to 17, which is probably unfamiliar to most of you. That first time I taught this course, I had never done this in my life, never heard of it. So I enjoyed it. It was something new for me. And knowing that it is real life, I had no idea how many false positives and false negatives existed. Okay? So a false positive is when you test positive for something and you actually don't have it. You know, you could be a drug test and they say you were doing drugs, the test comes back positive and you were actually negative. It could be a disease. You test positive for it. You didn't really have it. You're going through treatment. That's a false positive. A true positive is you're tested positive and you do have something. A false negative would be you test negative, but you actually have it. And that can be good or bad. I had a friend whose husband was having problems. He was under 45, so insurance would only pay for the pill that's a camera for a colonoscopy, and he tested negative. He kept telling them he had problems. A year later, they finally did a colonoscopy, and he was already in stage 4 cancer. So he had a false negative. He was actually positive. It just didn't pick it up with that method, not using the scope, the colonoscopy. So that was an example of a false negative that was bad. Okay. You have to be able to do these tables. Once you do the tables, then it's just back to section 16. It's just probability. Number of desired over number of total outcomes. Okay, so your tables will always be set up, or you will set them up, with a total, the number in your sample, the number of the population, whatever was tested. Okay. Then you have a total column. You have a column for positive test results, negative something results. The top row means you actually have it, or are positive. The next row underneath that means you actually don't have it. Okay? So once you learn to fill in the table, the computations are not bad. Okay? So let's look at, and they do usually ask you definitions here to describe something. So let's look at this one on the quiz. A dog allergy test for people has a 98% accuracy rate. You're going to have to be given an accuracy rate. If they just say accuracy rate, that's the same for both positive and negative. Sometimes you'll have a different accuracy rate for getting a positive or a negative. If they only give you one, it applies to both. You have to have a population. It says only 1% of the population has an allergy to dogs. Use a group of 100,000. So our population is 100,000, and you start there every time with the total amount. Okay? Then you need to find, they're going to tell you either a number that it actually has it or doesn't, or a percent. So you come here and fill out the total column next. It told us 1% of our population, so 0.01 times 100,000 have the disease. Okay? And we would get 1,000. From here, you fill in the rest of a column or row once you have one thing. Since we know there's 1,000 here and the total is 100,000, 100,000 minus 1,000 gives us the 99,000. Okay? It's not hard computations. You just got to start here, read the information, underline it. They're either giving you a percent or an amount or a fraction that do have it or don't, and then subtract to get the other one. Now you could have also went and taken 0.99 because they have to add up to 100%. You'd get the same answer. Okay? Now here's the part you got to be careful with. These 1,000 people actually have it. They are allergic. So to be accurate, the test would be positive. Okay? Make sure you put that in the right spot. Now how do we find how many it is? We use the accuracy rate. 0.98 times 1,000. And I know it goes in this column because if you actually have an allergy, to be accurate, your test should be positive. So 98 times 0.98 times 1,000 is 980. Now, you can do 0.02. I just usually subtract. If I know there's 1,000 and 980 test positive, that tells me 20 test negative. Okay. On the next column, those are people that are not allergic. So to be accurate, they should test negative. So right in here, accuracy rate is 98% times 99,000 gives us 97,020. Okay. Again, I subtract since I know it was 99,000 total. I just subtract my 9720 and get 2960. Now these are going to be high point questions on your test. Oops, 1980. Sorry. Somebody was getting ready to tell me. That's 1980. My total is 2960. My total is 9740. Okay? That's 1980. Okay? You're going to get points for filling in the chart and points for asking several, not just one question. Everybody following the chart. You start with the total given, then you find the total that do have it and don't using the information they gave you. Then you use what's an accurate test, what's the rate, times the total, and then I subtract to find the other one. You can also do 100% minus what this is and do the percentage. Now we're right back to section 16. If you test positive, okay, so how many total positive test results do we have?
2960.
Yep. What's the probability you do not have the allergy? How many don't have the allergy of those that tested positive?
1,980.
Okay. And this wants the answer as a reduced fraction. I've got 99 over 148. Okay. And what is this represent? This would be a false positive because they're going to ask you that on the test. This is an example of a false positive.
I have a silly question, Mrs. Yancey.
Okay.
Did you say on the quiz we actually fill in the blanks on the chart?
No, I'm saying on the test.
Oh, I was going to say because maybe that's why I missed it. Because
I may have said quiz, but I was meaning to say on the actual test, you get...
No, you didn't say either way. I just wanted to make sure.
We're filling in the chart, and then there'll
Gotcha.
be like 4 questions here, not one. So don't just think, oh, I'll skip this section. It's a high point section. Okay?
Right.
And it's really not, it's just, you're unfamiliar with it. It's not that complicated. It's just new. And you need to know probability anyway, so it's just filling in the table. There's several probability that are long questions with multiple answers that could be 8, 10, 12 points too. Okay? Let's try another one of these. Does anyone have one from the homework they would like to see? Who was that? Rachel had one. Let me look back and see if I can find the one she had. It was on transplants.
Yeah, I couldn't find it when I went back to look for it for some reason, but I had like Facebook messaged it to someone asking them if they knew how to do it, and she was like,
It's number 7, I believe. And I deleted number 8. You may have been one that a couple people had done that before. I think I may have deleted number... That's why you can't find it. I got rid of it.
okay.
After you did it, I think I got rid of 7 and 8.
Well, I didn't actually do it. I mean, I tried and failed and then asked somebody else, but...
Yeah, so some people had already done it, and I think I got rid of it. I know I got rid of number 8. I'm not sure if I got rid of number 7. The
I
reason
have a number 7, and that's actually one I had an issue with.
Okay, have you checked back lately? But let's go over it. Let me see.
Yeah,
if
I'm
I
on
did
it. I'm on it right now.
Okay, well, I should have it in my notes. If I did it, we did it. So
This is the brainless Aryan disease question.
I think it's number 7 here. Okay. Okay. Yes, that's it. Okay, a new medical test has been designed to detect the presence of the mysterious disease. Among those who have the disease, the probability that the disease will be detected by the new test is 0.74. Okay, so that's for a positive. Why I have a star here is they didn't give you, that's not for both positive and negative, that's just for positive. And then it says the probability that the test will erroneously indicate the presence of the disease in those who do not actually have it is 0.1. So that's not accurate, that's inaccurate, and they will not do this to you on the test. If I find it on the test, I would change it, because normally they tell you an accuracy rate. This one they gave you inaccurate rate. Okay? So what's going to happen, and 8 was even worse for those couple of you that did it. We always have a positive test result. We have a negative test result, or some result. Has the disease, does not have. And then we have our totals. So we start with the number of people, and it says use a population of 10,000. You always start in the lower right corner. And it tells us 12% of the people who take the test have the disease. So that's 12% of 10,000, 0.12 times 10,000, and that would be 1,200 that have it. Okay. So then we fill in the rest of this column. I just go my 10,000 minus my 1,200. You could do it with 88%, and you're going to get 8,800. Okay. And this is what was confusing. The accuracy rate for being positive, if you have a disease to be accurate, you should test positive. So that's going to go 0.74 times 1,200. So far, you're normal with what we've been doing. And we get 888. I just like to subtract. And I'd get 312 because that adds up to the 1,200. Okay. This is what throws you off. It says the probability the test will erroneously indicate the presence of the disease, which means a false positive is 0.1. So instead of doing this one, they gave you the information for this one. Where normally they would have been saying a 90% accuracy rate, and you'd have put 0.9 here, they gave you the rate of being inaccurate. Times 8,800, 880, then I subtract 7920, do my totals, 1768, and now you're ready for probability. And that question was on my next page. I'll look at it and bring it back up. If the test administered to an individual is positive, so conditional probability, out of only the positive test, what's the probability they actually have the disease? Okay, so test positive and have it is what we're looking for. So the total positive, 1768. How many actually have it? 888.
This is Yancey.
Yeah.
I'm sorry, could you slide it over a little bit to what would be our right, so that, because they appear to be, I have some extra information in my problem. It says the accuracy, hold on, the probability the disease will be detected by the new test is 0.74.
Okay.
However, the probability that it will erroneously indicate the presence of the disease in those who do not actually have it is 0.12. It is estimated that 16% of the population will have the disease.
So yours is going to be a 0.12 here.
Instead of the 0.1 there?
Yeah.
Okay, okay. I thought I had that in there when I looked at it earlier too, so I thought I had one extra thing thrown in there. I'm sorry.
And over here, instead of 12%, you would have done 16%.
Yes, exactly. My numbers are different over there anyway.
And right here, you need a 0.12 instead of a 0.1, and then you should.
Gotcha, gotcha. I thought I had that 0.1 thrown in there as well. I thought I just had an extra set of numbers. I'm sorry.
Nope. 0.12. If that's what yours says, then you would have a 0.12 here.
Okay, thank you.
Okay. And the WebWorks for a change was being very good. Every time I checked a fraction or a decimal, it was working either way. So that didn't give me any, it shouldn't give you any problems. It is on the quiz, wanting it just as a reduced fraction, but on here it was taking either way, and I rounded to different spots and it took different answers. So that was good. Okay. Does that answer your question, Rachel?
Mine was a little bit different. I think it was number 8 about the rejected kidney.
Oh, I'm sorry.
Oh, you're fine. Right. I think he wanted to hear about that one.
And that one has been removed.
Oh, hold on a second, bud.
I took 8 off because it was even harder than this one to decipher. They were giving you.
Yeah, I kind of didn't understand where I was supposed to like put anything or like So like I was getting confused about like what was testing positive and like what did that mean for the kidney kind of thing.
And that's why they've never given one like this or this on the test. Everyone they've given has been a straightforward, here is your accuracy for positive and negative, or here's your accuracy for positive and a different one for negative. Never have they given you one that was the accuracy for not being positive, for being inaccurate. And this one had it double and triple turned around, so I took it out. So don't worry about that one.
Okay, I just won't even worry about it. Thank you.
Okay. All right. How are we doing on time here? Do we have time for another one? 6:35. We do. Does anybody want to see another one? Any
Number
requests?
5.
And I think that was the one I did first in the video because it was a basic one. This is the kind
The polygraph, where it's saying if positive means they are lying.
Yeah. Okay.
That was a little confusing to me.
But it didn't have different accurate and inaccurate. Okay. Polygraph tests have an accuracy rate of about 90%. Okay. That means for both positive and negative. Okay. 90% of the people who lie and 90% of the people who are telling the truth. A company of 5,000 people. So you put this up here. So our 5,000 will go in the total box where we start. And what's nice about this one, it turns out there are 50 employees who will lie. They just gave us the number 50. It was given. We don't have to do any percent of a number. They just told us 50. So if 50 are lying out of 5,000, 5,000 minus 50 is 4,950. It turns out there are 50 employees. Okay. A positive test means you lie. A negative test means you're not lying. Okay. And it's 90% accuracy. So if you are a dirty stinking liar, the test should come out positive. So to be accurate, it would be in this cell right here. These liars, if the test is accurate, will test positive for lying. So you take your 0.9 times 50 and you get 45 for that block. Then I just subtract 45 from 50 and I get 5 in that cell. Okay. These are non-liars. An accurate test, if you don't lie, the test should show you do not lie. So that gives you a 0.9 times 4950 is 4455. Okay. I subtract that from 4950 to get the total there, and I have 495 that did not lie, but the test said they lied. So the total is 540. This total is 4460. Always make sure it adds up to 5,000 both ways, or the total. Okay. Then is everybody good on the table? Because once you get the table, we're just right back to the probability from 16. If someone does not pass the test, that means they lied, positive result. So our denominator is 540. Out of this 540, what's the probability they were actually lying? Would have been 45 actually lied. 0.083 or 8.3% were true positives. They tested positive and they were lying. Okay. Oh, there's
Yeah,
a
the table wasn't the issue. It was the wording of it. If someone does not pass their polygraph test, what is the possibility they lied? And it hung me up because if it was positive, then they lied. So it just really confused me, I guess.
Yeah. So what they were looking for was this column. They were positive test, and they did lie. What
Okay.
surprises me, the stuff in the book, most of it is actual data. And I had no idea there were so many wrong ones. I mean, if you look here, it'd be 495 that would be said they were lying and they were telling the truth. That's a pretty large percent out of 540. I guess that's why they don't use polygraph in court. That's pretty bad. And also this amount, this is what they always say, it can't catch a psychopath, where you actually were lying, but it says you weren't. So I had no idea tests could be that erroneous. Okay. All right. Good questions. The whole key to success in this class is staying on that pacing guide. And I know a lot of you got off on it after section 12. You came crashing down. You got to get back on doing what works. Reading the book, filling it in, watching the videos on Sunday, Monday, doing the web works, everything you can, and then coming to class with questions. Because you just can't do it starting Sunday night. You're just going to be lost, or Sunday afternoon, or when you come to class not checking, not knowing ahead of time, you're not going to get much out of class. Okay. We have one more section. And these are all on your test, so make sure you master them. It is on polling, which we just came off of a political season, and you'll still hear stuff out there. But had you been doing this during the campaigning season, you would have recognized things that you didn't even know you knew before. They almost always on the nightly news would say so-and-so was ahead of so-and-so, the margin of error is this. You probably never thought, what does the margin error mean? It means you don't poll everybody that votes, you just poll a sample. You can expect that that sample is right within plus or minus that margin of error. So if a sample came out to be 95% were for something and the margin of error was 3%, you wouldn't say 95%, you would say 92 to 98% is what you believe, because you take into consideration the margin of error. The population is the entire group your poll represents, not the number of people you poll. Okay? The population is that entire group that it represents. The sample or sample size is the number polled. We use N to represent the sample size. Now, margin of errors, to be 95% confident that your statistics are correct, you use the margin of error 1 over the square root of N. We only do 95% confidence level in this course. In real statistics, you can find what's the formula for a 99%, a 90%, a 93%. We only do 95%, and this is the formula. 1 over the square root of N. To make it a percent, you just multiply by 100 or move the decimal 2 places. Okay. Then you come up with your 95% confidence level. The result of your statistics, not the 95, plus this percent and minus it, will give you that interval from what to what. And you are going to have to write an answer on the test, type it in. What does it mean? And you need it to be very close to this. You need to start out, we can be 95% confident that, or it is with 95% confidence. Okay, because you're just picking a bubble, you're going to have to write it yourself on the test. That the lower limit percent to the upper limit percent of whoever the population is, believe or agree with whatever the poll is. Okay? Just be prepared. You're not going to click a bubble. You're going to actually write. Have to be ready to write the meaning. Okay? So, on number 2 here, we're given the margin of error is 2%. The result of the polling was 60%. So they're saying, what's the 95% confidence level? All you do is 60 minus 2%, you get 58, 60 plus 2%, and you get 62. So you can be 95% confident that 58% to 62% of high school graduates feel they were prepared for college. Okay? This just asks you the numbers, but that's what you would have to type. Okay. Anybody have a certain request on here? Okay. Let's look at.
I do. I'm sorry, I do.
Okay.
And this comes from our video series with Becky or Rebecca.
Okay.
One of the problems, it said, can it be concluded most Americans are extremely proud to be an American using this poll? And it was a 51.44% to 56.56%. And logic would tell me no, because that's barely over half. I can't say that's most Americans are extremely proud. But then her answer was yes, because anything over 50% is to be considered with confidence, I suppose, is what her point was.
It's not to do, the confidence is the numbers you gave, that interval. That's what the confidence level is. If you wrote an answer like you wrote, I don't think it could be counted wrong, because the question was not a good question. What is most? If it said the majority, are you sure it didn't say the majority?
No, I'm looking at it right now. It says, can it be concluded most Americans are extremely proud to be an American using this poll?
It should say majority, and then it's 50% or more. But the way, as long as you always explain it, to her, most would be anything over 50%. I don't think so either, but majority is.
Yeah.
And
my answer was no, and she answered yes.
Most of the questions, they usually had majority is the majority. Then it would be 50% or over.
Okay.
And you're right, it's more than half, so it's a majority, but who defines most? It would have to be defined, or give what your definition is, and you couldn't be counted wrong. Okay, very good question. Okay, so a Gallup poll of 1,627 Americans age 18 and over, conducted in May of 2000, found that 52% of the respondents strongly agree that K-12 schools should learn critical thinking, or should teach critical thinking. Okay, so they're going to ask you a series of questions. What's my sample size?
$1,627.
Yeah, that's how many. What's my population?
Americans age 18 and over.
You be as specific as they are, and Bridget is absolutely correct. You can't just say Americans. You can't just say those over 18. You have to be as specific as they are. Americans age 18 and over. And you don't put a number. Okay, your population isn't 1,627. That's who they polled as a sample of all Americans age 18 and over. So your population is just Americans age 18 and over. Okay. What's the margin of error? Our formula is 1 over the square root of n. N equals the sample size. So it's a very simple calculation. 1 over the square root of 1627. And I'm sure most of you don't know, I don't, the square root of 1627. So this goes easily in the calculator with the fraction button. Okay. 1, directional arrow down. Your square root button is your second key above your x squared. So you've got to press second and then the x squared, and that gives me my square root. And it's 1627. Hit enter. And the decimal form is 0.0247. Now, to find your interval, you're going to need to make that a percent. So you can move the decimal or multiply by 100, move it 2 places to the right. You get about a 2.5% is your margin of error. And you go plus and minus from the results of the statistics. It's a 95% confidence level, but the results of the statistics aren't 95. Maybe sometime it is, but you've got to look. It's 52. So to find your 95% confidence level, you take the result of your statistics, you subtract the margin of error, and you take it and add the margin of error. You're that sure that this is what you got, but you didn't poll everybody, so there's a range that could be just as good. So 52 minus 2.5 to 54.5%. And I remember always hearing on the news, one would be a little bit ahead of another in the campaign, but they'd say a statistical tie. They were taking into consideration the margin of error. Okay? So even though one you thought, well, they're better, how can they say they're tied? Because they really weren't, because it could be anywhere in that range when they put in the margin of error, and they were both in the same range. Okay? The one that was up here wasn't any closer than the one that was down here. Okay? And your results are only as good as how you poll, if it's truly random. Okay? Now you would have to write a sentence on the test. I think we usually use, we can be 95% confident. You have to have the opening something like this. Or it is with 95% confidence. We can be 95% confident that, now use your interval, 49.5% to 54.5% of, who was your population? Americans 18 and over. And what do they believe? Believe that critical thinking should be taught in K to 12. Okay? You need to practice writing this. Even though you're clicking the bubbles, you need to write it 5 or 6 times so that you're prepared to write it yourself on the test. Okay? Questions on this one? Anybody? Okay, let's go to the quiz question. Okay, I'll give you a second. I want you guys to try it. Type in your answer. Somebody I haven't heard from in a few minutes, tell us how to do this. I'll give you a second to try it. See if you're ready for the quiz.
Do we round the margin of error?
This is an odd way of putting it. it says round to the thousandths and leave in a decimal. Normally the margin of error, they have you put in a percent. And it's a good thing we're doing this one because it appears that they want this left as a decimal, but then your interval has to be in percents.
Okay.
Okay. I see two people got the same thing. Jill and Bridget. Okay. Oh, Jill's already got the second part. I know the people that have done the work. I can see it already. Who's taken the quizzes, discussion boards, who's done the web works. N is 1,001. Okay. Gallup poll is 1,001. Okay. So we find our margin of error, 1 over the square root of 1,001. Make sure you know how to do this in your calculator because it is on the test. Shall arrow down. Second square root, and that gives us 0.0316, and it said round to the thousandths, so it's a 6 in the 10,000ths, so it will become 0.032. Okay. Now, the 95% confidence interval for this statistic is what? You've got to look at the statistic number. It's 80%. So you go 80% minus, and you need to make this a percent. 0.032 times 100, or move the decimal 2 places, minus 3.2% to 80 plus 3.2%. So we would get 76.8 to 83.2. Okay, everybody following along? These are missed a lot. It's just because people get behind in this unit and they don't do the work at the end, and it's not that bad. They just got so hung up on section 12 that they've never got caught up. So don't miss these easy problems. They're not tough here. Okay, how would you write the sentence? It didn't ask you, but I know you are on the test. We can be 95% confident that 76.8% to 83.2% of who? Americans age 18 and over. And what was this about? Strongly agree that K to 12 should teach critical thinking. Okay.
Why do we use the 95% confidence rate for this unit? Is there like any special reason, or was it just like chosen at random?
They pretty much chose it at random. It is a common one. Like I said, you can find a 99% confidence level. You're going to have a bigger range because you're going to have a different formula for the margin of error for the 99% confidence level. Okay, this formula for margin of error only goes to where you can be 95% confident. And as you can see, because that's your sample size, the bigger your sample size, the less error you're going to have because you've polled more people. So they're assuming that it's going to be more accurate than if you have a smaller group. The larger that number gets, the smaller the margin of error.
So why I'm confused. Sorry. Why does it not change then? If our margin of error is smaller, then are we ever more than 95% confident?
Yeah, that's a whole different formula. Yeah, like you said, why did they pick They just picked 95% to learn that interval in here.
I guess even with problems, I don't understand why.
There is a table in statistics that will give you the formula for what margin of error would be if you want to be 99% confident, or 90. It's a different formula. Instead of n, it could be n plus 1 under there, or n plus something else can be the margin of errors, how they're figured out. Or you see what I'm saying? And you're right, it was purely random, except 95% confident is a common use one, but they don't take the time to explain and show you that you can find different confidence levels than 95. Okay, so let's say you're hired by some company and they want to know how many people like this new test product. They may want to know 99% confidence level. Then you'd be using a different formula right here.
Okay.
Does that make a little bit of sense?
Yeah, I guess.
I'll look up a table and send it to you that shows the formulas and statistics for different confidence levels. But in here, we're just using the one over the square root of n. And I don't like the way they just throw this in, and they're going to do it with a correlation coefficient coming up. They don't explain what it is very well or take you through the whole process. You're jumping into intermediate statistics with this, and we're not doing the background to it. So I can see why it's confusing to you. Okay, that there are different confidence levels. But you're right, it's random that they decided in this book to only focus on that one. So that is the only one you have to know. Normally, if you're a statistician, you have the whole charts, all the tables, and you could come up with any one that they want, and they will vary. The ranges, as you get more confident, the ranges get larger. Okay. All right. How many of you are going to come on Monday? I only had a couple in each class that said they couldn't. Hopefully most of you can come on Monday. I'll get that out to you. Because I wanted the people that have to take the test on Monday, Tuesday, or Wednesday, or Thursday before the class, I want them to be able to have a review. I don't, in the future, I'm not putting a class on Thursday. It's too late. I'm putting all mine on Monday and Tuesday because of test week. I don't, because some people take it before the review, and I don't think that's a good idea. They at least need to have the option to have a review. Make sure you're getting your project done. Do the reviews for the test. Come if you can. And like I'll have it all worked out on the YouTube playlist, my list, not the Becky videos. There is a difference. Go to our class YouTube playlist is where I'll put it in to watch that. Any questions? And I saw Javon just left, and I think there's some people I didn't get if they came in. Is Autumn Carpenter here? Cameo? Amber? Is Amber come? Amber's here, or was here. Okay. Michelle? That's unusual. She might be on spring. She might have told me. Okay. And Patrick? This is just like my face-to-face class on spring break weeks for kids. Okay. Erica, that's the only other one. Is Erica here? I don't want to count you absent if you're not here. There's a caller. I don't know who you are. Erica, Patrick, Cameo, or Autumn. Last call. All right. If anybody has any questions, I'll hang out for a few minutes if you want to ask me any more questions.